Hello, Algebra 2 students. Today we will do 7.1, 7.2 Notes, Exponential Growth and Decay Models, and Compound Interest. Here's what an exponential growth model is. When a real-life quantity increases by a fixed percent each year, the amount y is modeled by the following equation. Y equals a times 1 plus r to the t power. So on the left side, we'll identify what some of these things are, and just know that y is the final amount or the ending amount. A is the initial amount, so it is the number right after the equal sign. R is known as the growth rate, and it's written as a decimal, so you can actually do calculations. T is the time, and 1 plus R, the stuff in parentheses, all of that stuff is known as the growth factor. It's growth because it's 1 plus a number. And examples of exponential growth models include population growth, bacteria growth, appreciation of certain things like appreciation of classic cars, that's known as an exponential growth model. So let's do two examples. Number one, in 1970, the population of Kern County, so I'm going to underline 1970, in Kern County, California, where Bakersfield is located, was about 330,000 people. So that's the population. From 1970 to 2000, the county population grew at an average annual rate of about 2.4%. So this is your rate, but it's not written as a decimal. Write an exponential growth model giving the population Y of Kern County T years after 1970. Then, approximately how many people lived in Kern County in 1990? So we will answer that question. But before, let's go ahead and write our equation. So y equals a times 1 plus r to the t power. We want to know the ending population, so we want to know what y will be. We know the starting population, A, is 330,000. Then you have the 1 plus R, the growth rate as a decimal is, remember you take the percent sign off and you move the decimal point over 2 places to the left, so it'd be 0.024. So it'd be 1 plus 0.024 to the t power. And that is our model. So this is the first part. But I'm going to go ahead and simplify the stuff in parentheses because we can do that. That's 1.024 to the t power. So this is part 1. Just write the model. Part 2, approximately how many people lived in Kern County in 1990. So we are going to use that model and we are going to replace t with a specific number of years. So 330,000 times 1.024, t would be 20 because 20 years have passed since 1970. So you put that in your calculator, and if you don't have a calculator, you really need to get one by now. So you need just a basic scientific calculator. You can plug it in just how you see it if you have a nice advanced calculator, but if you don't, you want to do this first. So do 1.024 to the 20th power. How do you do that with a phone? You enter 1.024 in your calculator when you're holding your calculator sideways, and then you hit this button called, it's in the second row when you're in landscape mode and it's x to the y, and that'll give you a value. And then you can multiply by 330,000, and your answer would be 338. Oops, sorry. It'd be 530,289.55. So y equals about 530,289.55. Let me see if I entered that in correctly. So 1.024 to the 20th power. So you want to hit the XY button and then hit 20, hit enter, and then times 330,000. Yep, and that's what I got. So the button you want to hit on your phone, is this X to the Y button. Okay. Let's do another problem. A rabbit population beginning with 25 rabbits doubles twice per year. How many rabbits will there be in 3 years? So again, let's start with our equation. Y equals A times 1 plus R to the T power. The initial rabbit population is 25. We have 1 plus R. So here we need to think about what our growth rate is. If it doubles twice per year, that's going to be 100% growth rate. And so the growth, so as an R value, 100% is equal to 1. Because you take off the percent sign and you move your decimal point over 2 places, it's just 1.00 or just 1. So I'm going to replace R with 1. And T, it doubles twice per year, so it's going to be 2T. Yeah, and then we could just simplify this stuff in parentheses. So 25 times 2 to the 2t. Now you can't multiply 25 times 2 and call it 50. You have to do the 2 to the 2t first. And we are going to do that. So y equals 25 times 2. And it said, how many rabbits will there be in 3 years? So you're going to replace that t with 3. So you have 25 times 2 to the 6th power. So you want to do the 2 to the 6th first. That's 2 times 2 times 2 times 2 times 2 times 2. And that's 64. And 25 times 64 is going to be 1,600. So your answer is 1,600 rabbits. Which reminds me, for problem number 1, we needed to actually answer our question, which I did not do. So I'm going to go back and erase something. There we go. And so our actual answer was 530,000. Let's just round it to the nearest person. So 290 people. Your answer must make sense too. You can't have a decrease if the population is increasing. All right, now let's do exponential decay model. Very similar, just one thing that's different is instead of a growth rate, you're going to have a growth decay, and you're going to have 1 minus R in the parentheses. So the initial, A is the initial amount. R is your growth rate, again as a decimal. T is your time. And 1 minus R is called the decay factor. Y is your final amount. And it doesn't have to be y. If it's a real life variable, just know that on the left side, your final amount equals the initial amount times the decay factor raised to the t power. So an example would be depreciation of goods. When you buy the latest phone, after a couple of years, actually initially, like right away, it's going to lose in value. Same with when you buy a car off of a lot, it's going to depreciate right away. Population also goes through a decline when you have diseases, like any kind of plague. It reduces the population. Let's do a couple of examples. Number one, a new snow machine costs $4,200. The value of a snow machine decreases, so that tells you it's a decay, by 10% each year. Write an exponential decay model giving the snow machine's value in dollars after t years. Then estimate the value of the snow machine after 3 years. So going back to our equation, y equals a times, this time it's 1 minus r to the t power. We want to know the final amount. We're going to write a model. A is 4,200 because that's what it initially cost. 1 minus 10% as a decimal is 0.10 to the t power. So that is y equals 4,200 times 1 minus 0.10 is 0.90. If you can't subtract, use a calculator. Don't try and do things that you will make a mistake with. And so this is your model. And then we're going to use that model to estimate the value of the snow machine after 3 years. So in a calculator, you would do 0.90, or I'm sorry, on your phone, enter 0.90, then hit the X to the Y button, then hit 3, then hit enter or equal. And that'll give you some number, and then multiply it by 4,200. The A gets multiplied last. So that particular one will give you an answer of 3,061.80. So it will be, and then since this is in dollars, $3,061.80. So it decreased, and after 3 years, it went down quite a bit, over 1,000 actually. Number two, a new car costs $32,000. The value of the car depreciates, so depreciates by 15% each year. Write an exponential decay model giving the car's value y in dollars after t years, then estimate the value of the car after 4 years. So y equals a times 1 minus r. You need to figure out if it's growth or decay, and this one is decay because you saw the word depreciate. So the initial cost of the car is $32,000. You don't even have to put commas. 1 minus, let's see, 15% is 0.15 to the t power. It says y equals 32,000. 1 minus 0.15 is 0.85. And this is our exponential decay model. And now we are going to use that model, and we are going to estimate the cost, or estimate the value of the car after 4 years. So we are going to replace t with 4. So 0.85 to the 4th power, and then multiply that by 32,000, and it will give you $16,704.20. Cars are some of the things that depreciate the most, or the fastest, sorry. So be very careful in your future endeavors when you want to buy a new car versus a used car. All right? Now, the back page is compound interest. This is some fun stuff. And that's going to be really relevant to you, maybe even now if you happen to have money in the bank. But what uses compound interest? Well, banks use compound interest. For instance, in banks, your parents may have set up savings accounts for you guys. But loans also have compound interest, and people take loans when they're going to buy a car, buy other property, so on. Then there's credit cards, etc. Those are just a few. I'm not going to go into the details. This is not a financial class, but we do offer a financial literacy class for later if you'd like to take it. So the compound interest is interest paid on the initial investment. So you have this amount that you initially start with and on previously earned interest. So the equation is A equals P times 1 plus R over N to the NT power. Now interest is paid only on the principal, or I'm sorry, there's another equation, and we rarely, in real life this is rarely used. And because it's interest paid only on the principal, the initial amount that you put in, you want money, you want to make money on money that's already accruing interest. So if you started with $500 and next month you had $510, you want to be making money off the $510, not the initial $500. And so here's some of the variables, or here's all the variables we're going to define. So the letter on the left side, A, is the final amount. P is your principal. It's not a person, it's an initial amount. Just like on the previous page, we used little a as our initial amount. It's basically the location. After the equal sign is your principal. R is your annual interest rate. And that's the key here. It's annually, yearly. And again, you can't do any calculations unless you write the rate as a decimal. N, so these are new things, is the number of times interest is compounded. Compounded. Okay. And then T is going to be time in years. So where we didn't specify on the previous page, this is going to be time in years. So yearly is keywords here. And here's some banking vocabulary. So principal is known as the initial amount. On the left side, or the rest of these words, the 6 words, are known as yields. So annually means once per year. So N would have to be, because remember, N is the number of times interest is compounded. So N equals 1. Monthly, there's 12 months in a year. So it'd be 12 times because the total in a year. So it'd be compounded monthly. Weekly, 52 weeks in a year. If you didn't know this, then shame on you. Now you do know. Semi-annually means twice a year. Quarterly, just think of quarters. Well, just think of school. You have first, second, third, fourth quarter. So 4. And daily, 365. All right, and we're going to use this information to do some problems. Let's do the first one. You deposit $5,000, yay, you're rich, in an account that yields 3.6% annual interest. So you start off depositing this much. Here's your annual interest rate. Find the balance after 2 years if the interest is compounded with a given frequency. So we're going to do 2 problems in one, basically. First one, semi-annually. So A equals, and I'm just going to use this equation right here, but I'm not going to write it out. Right? So P, the amount that you start with is $5,000 times 1 plus R. So be really careful. Take off the percent sign and move this decimal over 2 to the left. So you're going to have to put a 0 placeholder. Can't miss these kinds of things. So 1 plus 0.036 divided by N, and semi-annually means N equals 2. So I should probably write that down here. And T, and the equation, so N is 2, so put 2 again. And the time is t. So let's write that down. T equals 2. We knew t equals 2. We knew n equals 2. And now you just have to do the math. What do you do first? You have to do the fraction first. So 5,000 times 1 plus 0.036 divided by 2 is 0.018 to the fourth power. And then you do 5,000, or I'm sorry, then you do the stuff in parentheses, add those two, and you get 1.018. And this is where you can use your phone. Do 1.018 to the fourth power, so multiply by itself 4 times, and then times it by 5,000. And you're going to get A equals $5,369.84. Now let's compare that with the quarterly payout. Quarterly means that interest will be compounded 4 times per year. So A equals 5,000 times 1 plus same interest rate, 0.036, but this time n is 4, so put 4 in the denominator, and n is 4 again, and your balance after 2 years. So that changes. So you have 5,000 times 1 plus 0.009 to the 8th power. 4 times 2 is 8. That's 5,000 times 1.009 to the 8th power. And you remember, you have to do this first. You cannot multiply 5,000 by 1.009. And then that'll give you an ending amount as $5,371.55. So notice, oops, I should have boxed in this answer. If you get your interest compounded quarterly, you get a better payout. Now it's not even $2 more, but still it's better than making less. So this is a better payout. Either way, if you're not going to use the money, why hold on to it? Put it in a bank and let it grow interest. Okay, number 2, you were charged 8.8% compounded monthly. The first thing you want to do is say, oh, that's n equals 12 on your credit card for a balance of $2,500. If you did not make any payments on the card, how much would you owe in total after 1 year? Okay, so again, our equation, A equals your initial balance was $2,500 because you bought a laptop, you bought this, and you have to now pay it back. 1 is our beginning number plus our interest rate. So our interest rate, that is 0.088 because you're moving that over 2 to the left. So that goes in your numerator divided by compounded monthly, so 12 to the 12 times t, and t is 1 year. So t equals 1. There we go. And I am not going to tell you what 0.088 divided by 12 is. I'm just going to tell you that I did all of this work and I got A to B. And you should try it too on your phone, that you get the same thing if you don't have a calculator handy. So your ending amount is $2,729.09. This is not good. You only paid $2,500 for your goods, but because you charged it on a credit card, you have to pay the bank some money. So this is $229.09 more than you actually charged to your credit card. So the moral of the story is try and make some payments instead of trying to pay something off all at once at the end. Oh, I didn't need to box that up, but maybe I just wanted to emphasize that, hey, this is important. All right, and our last one. You put $1, yes, one gigantic dollar, into an account that yields 5% compounded daily. So compounded daily means N is 365. Your interest rate, 5%, take the percent sign off and move the decimal over 2 places to the left, and t is 1. So your ending amount, your final amount, is equal to your beginning amount, which is $1, times 1 plus your annual interest rate, 5%, divided by 365, to the 365 times 1. And again, I put all that in a calculator, and I got $1.05. So what does this mean? It means after 1 year, if you don't use that dollar, you're going to end up with $1.05, and you are 5 cents richer. And those are your notes for today. Have a great day, Algebra 2 students.